Hi students. So in last class we studied about the different types of speed and the different types of velocity. Okay, and in today's class we will study about the motion in one dimension. Here we will be studying today about the graphical representation. Okay, graphical representation in linear motion. That means the terms we have learned till now, that is displacement and velocity. How do we frame a graph between that displacement or that velocity, that vector quantities, with respect to time? Okay, so let us begin the video and we will understand later on how we can actually frame it. Okay, so now I'll be starting with the displacement time graph. Okay, the displacement time graph. Now, so in displacement time graph, let us take a few examples and see how can we actually frame this particular graphs. Okay, so the first graph we'll be studying about is when a body is at rest. Say a body is at rest. So if I frame the graph, always you should remember, whenever you will be doing a graph in this type of a linear motion, the x-axis will always represent the time. The x-axis will always represent the time, and the time unit can be in second or it can be in hour. And the y-axis will always represent the part with which this graph is framed, that is the displacement. Here it is the displacement with which the graph is framed, isn't it? So in y-axis it would be the displacement, and the unit can be in meter or kilometer. Okay, let me take in meter. Now for the first case, that is in at rest. Okay, so we know if a body is at rest, then with respect to time, say I am standing here, I am at rest, I am standing here. So as the time is covering, isn't it? Now it is 1 second, now it is 2 seconds, now it is 3 seconds. So with respect to time, am I changing my position? No. From the camera, say I am at 2 meter distance. That means with respect to time, say this is 1 second, 2 seconds, 3, 4, 5. With respect to time, the displacement will not change. That means if I am at 2 meter distance, with respect to every second, I will always be at 2 meter only. With respect to 1 also, I will be at 2 meter. With respect to 2 seconds also, I will be at 2 meter. With respect to 3 seconds also, I will be at 2 meter. 4 seconds, 5 seconds, with every second I will be at 2 meter distance only. So here it is 3. So this graph, this particular graph represents a body at rest, a displacement time graph for a body at rest. Now, it doesn't end here. Okay, so in exam, what they will do, they will ask you to find certain data from this graph. So how to find that? Okay, so initially we have to see two things in a graph. Two things we have to see. That what the area of a graph is giving, and secondly what the slope of this graph is giving. These two are very important, the area and the slope. Now first of all, the area. Now what is actually area? Whenever we see a geometrical figure, say here if we take this whole figure, it represents a what? Rectangle, isn't it? If I join this line, then it represents a rectangle, this particular figure. So what we do in case of rectangle, the area is length into breadth, isn't it? Here the length is this part, that means it is the time. The length is showing the time. And the breadth part is in the y-axis, that means it is the displacement. Understood? And we have studied that time into displacement will give us nothing. Okay, time into displacement will give us nothing. Yeah, displacement divided by time will give me velocity, but their multiplication will never give us anything. Okay. So that means area of a displacement time graph will give us nothing. It will not show any values to me. Practically it is not possible. Now what about slope? Slope, if we know, the formula of slope is y2 minus y1 by x2 minus x1. Okay, slope, in other words, it is known as gradient. Say you are climbing a step. What is the particular height, or what is the particular shape between the two steps? This particular place is, this particular shift is known as the slope. Here also this particular shift is known as the slope. Okay, in order to find that, what we do, we apply this formula y2 minus y1 by x2 minus x1. Now you will be confused what is particular y2, y1, x2, x1. Okay, these are actually coordinates of this point. Say this particular point, the initial point, this point is marked as x1, y1. Here the first value represents the value of the x-axis at that point. See, here the value of x-axis is what? See, it started from 0, isn't it? So if I draw a perpendicular from this point downward, it will strike with 0. So the value of x1 here is 0, and the value of y1, that means the value of y here. Here the y is represented by 2. So 0, 2 is the value. Similarly, the last point, in this case the last point is noted as x2, y2. Remember one thing, I can take x1, y1, x2, y2 at any particular point if I want so. Okay, in order to make it easier, I am taking the initial and the last point. Okay, now the final point x2. See, here if I draw the perpendicular, it strikes with 5, isn't it? So value of x here is 5, and y, if I draw the perpendicular along the y-axis, it will give me what? 2, 5, 2. If I put the values here, it will give me what? 2 minus 2 divided by 5 minus 0. That means 2 minus 2 will practically give me 0. That means the slope is here 0. Now what do we represent by slope? It is very interesting. See, what do we represent by slope? So slope basically means y-axis divided by x-axis. Now in y-axis we are representing displacement. Remember, in y-axis we are representing displacement. So displacement divided by, in x-axis it is represented by time. So displacement by time gives me what? Velocity. So that means here the velocity is 0. That means in this type of graph, at rest, the velocity of a body is 0. So these two data are very important. The area and the slope of that particular graph is very, very important. You have to know this part very carefully. Okay. Now, next is when the body is actually moving. Okay, when the body is moving. But now the movement, as we know, when a body moves, it should have a velocity, isn't it? Okay, when a body ever if it starts moving, it will always have a velocity, and we know practically that two types of major velocities are there: uniform and non-uniform. See, average and instantaneous velocity, that is actually for calculative purposes, but in reality uniform and non-uniform is the majority part of the velocity classification. Okay, now the second case, if the body is having a uniform velocity, it is at motion and it has a uniform velocity. Okay, let me consider it at motion only. Okay, now if the body is at motion, then what type of graph it may have? Now see, say 1, 2, 3, 4. This is the time I am representing here, time in second, and here the displacement in meter I am representing 1 meter, 2 meter, 3 meter, 4 meter. Now say I'm taking an example. Say you started from here to your school and there is no traffic. As I mentioned the example earlier, there is no traffic here. You are going to your school. Now in 1 second you are running to your school. Okay, in 1 second, say the distance that you covered is 1 meter. So the point will be here. In 1 second the distance covered is 1 meter. Understood? In 2 seconds, say the distance covered is 2 meter. In 3 seconds, wow, in 3 seconds the distance covered is 3 meter. In 4 seconds, the distance covered is how much? 4 meter. Okay, so if I actually add up all this point, okay, as you all know, my straight line is not actually straight here. Okay, so if I practically join these particular points, I'll get a somewhat straight line here. Okay, actually it will come a straight line, but I can actually draw a particular straight line. Okay, this straight line will represent a body moving in uniform motion. Now, how come it is in uniform motion or in uniform velocity? How do you know that? So here also I'll be finding certain data here. What data will be finding from here? See, as I told earlier, first I have to find the area. So area, if I find, I know in a displacement time graph, area means what? Multiplying this x-axis and y-axis, this x-axis and y-axis. X-axis it is time and y-axis displacement. These two, if I multiply, it will give me nothing. So the area here will practically give me nothing of information. Okay. Next is your slope. Slope practically means, as I explained earlier, it practically means dividing the y-axis by x-axis. So in y-axis there is displacement and in x-axis there is time. So displacement and time will give me velocity here. Okay, so the slope of this particular graph will give me velocity. Now let me find the slope, and this will make up the point 3. So now if I find actually the slope here, say I have taken first 2 points, say here to here, these 2 points. Here it is the origin, okay, and you always know in a graph the origin is 0, 0. Y is actually 0, x is also here 0. And here then x is 1, y is 1. So if I apply this formula y2 minus y1 by x2 minus x1, this y2 is 1 minus x1, sorry, y1 is y2 minus y1, so it will be 1 minus 0 divided by 1 minus 0, this will give me 1. Similarly, if I take another point, say y3 minus y2 divided by x3 minus x2, so I have taken another slope, where? From the here to here. If I take these 2 points, here it is 1, 1, here then it will be what? 2, 2, isn't it? So if I do this particular sum, what I'll get? 2 minus 0 by 2 minus 0. See, y3 is, this is your y3, this is your y3 is 2 and y2 is 1. Okay, so 2 minus 1. Okay, 2 minus 1 divided by here also x3 is your 2 and x2 is your 1. So 2 minus 1, it will give me 1. 1 by 1, the answer will be practically 1 itself. Understood? So that means the slope is always equal. From here to here also the slope is 1. From here to here also the slope is 1. From here to here also the slope is 1. And what do we mean by slope? Slope means if I connect this perpendicular line from these 2 points, if I connect this particular line, then how much height it is covering, okay, how much particular height it is actually covering from this point to this point. Okay, so here the slope always it is 1. From here to here, from here to here, from here to here, the slope is always 1, and we know the slope gives me velocity. That means the velocity is uniform all through the graph. Understood? The velocity is the velocity is uniform all through the graph. So this velocity is a uniform velocity. So the third points come that velocity is uniform in this particular graph. And number 4 point, it is very important. Now we always know if the velocity is uniform, that means the velocity is not changing. If the velocity does not change, then will there be any acceleration for that? Will there be any acceleration for that? If your answer is no, or if your answer is yes, you have to verify it. In order to verify, please visit my earlier videos. In there I have discussed about acceleration. Okay, if you see that video, you will understand that acceleration is 0 if the velocity is uniform. If velocity does not change, acceleration is 0. So from this graph we learn these 4 particular points, that the area of this graph will give me nothing, and slope will give me velocity, and the velocity is uniform, and the last point is acceleration is 0. Now come to the third point. Now if the graph for motion appears to be in this manner, say it is in this manner, now what does it represent actually? So here also the graph started from 0. This is the x, this is the y, this is the displacement in meter, this is the time in second, and say it is 1, 2, 3, 4, and here for 1 say it is 1, here it is 2, 3, 4, 5, 6. For 2 it will give me 2.5, for 3 it will give me 4, for 4, okay, if I extend this particular graph, then it will give me exactly like 9 or 10 it will give me. Okay, so here what will be getting, see here also the area will give me nothing, the slope will give me velocity. These two will remain constant here because here it is displacement, here it is time. कहाँ जाना है उसको लेके? डिस्प्लेसमेंट बाय टाइम और डिस्प्लेसमेंट टाइम ही तो करना है. इनटू करने से कुछ नहीं मिलेगा, डिवाइड करने से हमको क्या मिलेगा? वेलोसिटी मिल जाएगा. ठीक है, और स्लोप जब निकालेंगे ना यहाँ पे, ये देखो ये वाला बहुत इंपॉर्टेंट है, ये थर्ड पॉइंट यहाँ पे बहुत इंपॉर्टेंट है ये वाला ग्राफ में, क्योंकि स्लोप जब निकालेंगे तुम इस 2 पॉइंट में देखो, इस 2 पॉइंट में ये वाला एप्लीकेबल है, isn't it? Here also it is 1 1 and 0 0, so the slope will give me 1 itself. But from here to here if I go, here what is the point? The x-axis is 2 and the y-axis is 2.5. So if I apply this formula here, it will be 2.5 minus 1 by 2 minus 1. It will give me 1.5. Sorry, it will give me 1.5 divided by 1, so the answer will come as 1.5. So the slope is not same here. The slope is not same here. That means the velocity, the slope gives me velocity, isn't it? So the velocity is not same here. That means the velocity is not uniform. Velocity is non-uniform in this case. And what about the acceleration? In order to see the acceleration, we have to practically see what is the velocity change here at every moment. If we see that the velocity change in this particular graph is uniform, if I find the slope for every particular graph, say here the slope is 1, here the slope is 1.5, say here the slope is say 2, then the increase is same, isn't it? From 1 to 1.5 the increase is 0.5. From 1.5 to 2 the increase is again 0.5. Again see, here also if it comes 2.5, then again the increase is same. Then and then only the acceleration will be uniform. And if this gapping or if this slope is not same everywhere, then the acceleration will be non-uniform. That you have to find practically. Okay, I'll be doing a sum. In that I'll show how to find that practically. Okay, but that is for a later video. Okay, video भी तो बनाना है ना. अच्छा. But we can surely tell that in this case acceleration will be there. Okay, whether this acceleration will be uniform or non-uniform, we have to find that by doing the slope for every particular coordinates. We have to find the slope, and then we have to find whether the acceleration is uniform or non-uniform. Understood? So for the next part we'll be doing about the velocity time graph.